And we've talked about our derivatives quite a bit. We've practiced them several different ways. We know there's more than one definition we can use to get our derivative. And we know it is giving us a rate of change. So how, like the slope of a tangent line if you're looking at a graph. And so we know how to draw a rough sketch of the graph of a derivative just by looking at those. So let's talk specifically for a moment about a constant function. That was like that very last question. We did the fourth derivative. And by the end, we were just doing the derivative of our function had become -6. And what happened when we did the derivative of that? Remember what we got? We got 0. If you think about a graph, if it's just y equals a number, that's a horizontal line. What's the slope of a horizontal line? 0. So, horizontal lines have a slope of 0, so the derivative is always 0. That means now we know that. So if I give you the derivative of a constant, you don't have to work it out anymore. You know it is automatically just going to be 0. So if I ask you for the derivative of y equals 8, no work required, you can just tell me that is 0. Derivative of any constant is 0. All right, I'm not going to prove all of these, but I'll give you this one. If you were reading a calc book, they would give you the proof of it, the explanation. If our function is just a constant, the derivative is the limit as h approaches 0. F of x plus h. What's f of x plus h? Just c. Minus, what's f of x?
C.
Over h. So you have 0 over h. 0 divided by anything is 0, and the limit as h approaches 0 of 0 is 0. Okay, so this is now something we know. Derivative of any constant is 0. Let's try to figure out any other shortcuts that we might have. You might have noticed when you guys are working through those, I could usually look over your shoulder and tell you if you've gotten the right answer or not. Because there are some things that we can use to help simplify this. If I'm talking about a power function, so like x to a power, as long as that exponent is positive, because negative exponents have some different rules, because what does a negative exponent do? Yeah, it puts it down on the bottom, so we might have to think about those a little bit more. But for now, if we're just talking about those, let's start with the most basic one. If my function is just x, that's y equals x. What's the slope of that line? 1. So what do you think the derivative of that would be? The derivative is just the slope of the tangent line, which would just be 1. Okay? If my exponent is 2, then let's work it out. So if my function, that's like saying my function is x squared. So if I were doing the limit as h approaches 0, f of x plus h minus f of x all over h. If I work this out, x plus h squared turns into x squared plus 2xh plus h squared minus my x squared divided by h. Then what happens? X squared cancels. Then I can take an h out of everything that's left, so I get the limit as h approaches 0 of 2x plus h, which is Alright, so we know the derivative of x is 1, because it was just a line, we could think about it. the derivative of x squared is 2x. Let's try some more. If it's to the third, so my function is x cubed. So I did the limit as h approaches 0. F of x plus h, so that's x plus h cubed, minus f of x, so minus x cubed, all over h. All right, x plus h cubed. We've worked that one out quite a few times. So it's x cubed plus 3x squared h plus 3xh squared plus h cubed minus my x cubed all over h. What happens? X cubes cancel out, and everything that's left could be divided by h. So we get 3x squared plus 3xh plus h squared. If I plug in 0 for my h's, we get 3x squared. All right. Do you have any predictions what the derivative of x to the fourth might be?
4 x cubed.
Let's see if you're right. So x plus h. If you take x plus h to the 4, that's where we're going to have to begin. Minus x to the 4 over h. Is everybody with me on these? Okay, so if we were to multiply this whole thing out, you get x to the 4th plus 4x cubed h plus 6x squared h squared plus 4xh cubed plus h to the 4th minus x to the 4th. Do I need to show you the work, how I got that? You guys trust my multiplying? What happens now? X to the 4th drops, and everything that's left can be divided by h, so we get 4x cubed plus 6x squared h plus 4xh squared plus h cubed. If I put in 0 for all my h's, we got 4x cubed, just like you guys predicted. Did everyone see the pattern? Do you get how they got the 4x cubed? So think about when my function was x, my derivative was 1. My function was x squared, the derivative was 2x. When the function is x cubed, my derivative is 3x squared. My function was x to the 4th. My derivative is 4x cubed. What am I doing?
Taking the front number times the coefficient and subtracting 1 from the next one.
My exponent's coming down, the 2 comes down, and I subtract 1. That works here too. The 1 comes down. If you subtract 1, anything to the 0 power is 1. So that's how that first one is working as well. Okay, so if I said x to the 5th, my derivative would be, if I said x to the 701st power, what would my derivative be? Do you guys all see that pattern? So that is a really nice result. That's called our power rule. That means we don't have to work all of those out anymore. We now know if we have the derivative of x to a power, we can bring that exponent down, keep the x, and subtract 1 from our power. That is the pattern. If you are writing the equation of a tangent line, we know the derivative is the slope of that tangent line. Sometimes you might be asked to write the equation of a normal line. The normal line, we did it way back at the very beginning, but remember the normal line is anything that's perpendicular to the tangent line. So, the derivative gives you the slope of the tangent line. The line perpendicular to that is called the normal line. All right, so take a second and see if you can find these derivatives for me. So what's the derivative of x to the 6th? Okay, remember y prime is just another thing for derivatives. So this is, okay, dy dt is another way to write derivative. I tried to throw in a lot of our notations to get used to them. So that one would be? Good. Try to keep the variables given. I know it's really easy to put x's for everything, but try to keep the variable we had. Derivative of r to the 3rd. 3r to the 2nd. All right, did you guys get all of those? So let's talk about if we have something that's written a little bit differently. Is there any way we could use our power rule to find these derivatives? If I have 1 over x squared, how could I rewrite that? So x to the negative 2. So then if I do my derivative, the derivative says the exponent comes down in front, so the negative 2 comes down. You keep the x. What do we do to our exponent? Subtract 1. Negative 2 minus 1? Negative 3. And you could leave it like that. You could change it back into fraction form if you wanted. But that gives me negative 2x to the negative 3. All right, if I said the cube root of x squared, how could I rewrite that so it was a power function? X to the 2/3 power. So my derivative, try to make sure that you're labeling these. It is f prime, so you don't get confused with what your function was. Exponent comes down. We keep our x. And we subtract 1 from the power. 2/3 minus 1. All right, are those okay? So let's look at this problem. If I ask you to find the equation of the tangent line and the normal line to this curve, f of x equals x radical x at the point 1, 1. To write the equation of a line, we need a point and we need a slope. How do we get the slope? Right, but what do we have to do first so we have an equation to find our slope? The slope of a tangent line is the same thing as your derivative. So we have to find our derivative first. Now, do we have a rule for doing the derivative of things being multiplied? No. So I have to rewrite this. I have an x. A square root is x to what power? So if you're multiplying, what do you do with those exponents? Add them. So this is like x to the 1st times x to the 1/2. So that's x to the 3/2 power. All right. So our derivative, the exponent comes down. Keep your x, subtract 1 from the power. So it's a 1/2. Okay, let's get our equation of the tangent line. We need a slope. All we have to do is go to our derivative and plug in our x value, which was 1. So that's 3/2 times the square root of 1, which is 3/2. So now we know our slope. So you can either plug into y equals mx plus b or the point slope formula. Most of you are using y equals mx plus b, so I'll do that. So my y-intercept is -1/2. So our equation is y equals 3/2 x minus 1/2. Is that one okay? The normal line. We know this is perpendicular to the tangent line. So if the tangent line had a slope of 3/2, what's the slope of my normal line? -2/3. Flip it and change the sign. Our point is still 1, 1. So plug into y equals mx plus b. And so the normal line, which is just the line perpendicular to your tangent line, is y equals -2/3 x plus 5/3. Is this going okay? Any questions on that? I want you guys to take a second and try this. So our derivative is 4x cubed. So for the tangent line, your slope, what am I plugging in for x? So -2 cubed is -8 times 4 is -32. But I want the equation of the normal line. So what would be the slope for my normal line? Right, you flip it and change the sign, so positive 1/32. So then plug into y equals mx plus b. So 16 is like 256/16 plus 1, so 257/16. So we get y equals 1/32x plus 257/16 for the normal line. All right. So to finish today, I want to stick with this derivative concept and add a few things to it. I have place, I can do the proofs of this stuff if you want, or if you just trust me, we can roll with it. I've done one proof today, so I don't have to do them all. The first one, if you have a constant times a function, that constant just gets multiplied by the derivative. Okay, so everything we've been doing was just x to a power. But what this tells me is if my function is like 5x to the 4th, your derivative is just 5 times, what's the derivative of x to the 4th? So it becomes a 20x to the 3rd. Okay, so if you have a coefficient, that doesn't mean we can't use our rule. It just gets multiplied with the derivative. So basically now when that exponent comes down, it multiplies with whatever number is in front. Okay, do you guys want me to prove that one? Or do you trust me?
I trust.
Trust me? Oh, yes, sir. All right, so knowing that, see if you can write down these two derivatives for me.
3 times 4x.
to the third, good. Here, the derivative of negative x. Okay, so the negative just stays. X just has, you might remember the rule, but if you don't, it's an exponent of 1. 1 comes down, if you subtract 1, it's 0. What's x to the 0 power? So we just get negative 1. Did you guys get those two? Okay. The second rule. As long as both of your functions are differentiable, you can do the derivative of each individually and add them together. So if you have functions being added, you can just add their derivatives. If things are being subtracted, we can just subtract their derivatives. That means if we have multiple terms, we just do the derivative of each term and keep our plus and minus signs the same. Do you guys want me to prove that one? You don't feel the need? So, if I give you this huge polynomial expression, if I had given you this one last week when we were doing our limit definition, you probably would have cried for a little while. Because you would have to do x plus h to the 8th power and to the 5th, and then try to simplify all this out. It would have taken forever. But now, we can just do the derivative of each term. The derivative of x to the 8th. Here, I'm going to, at least for today, write out what I'm doing, but if you are okay without doing that, you're welcome to go ahead and simplify as you go. The 12 will be multiplied by the derivative of x to the 5th, so 5x to the 4th. Minus 4, what's the derivative of x to the 4th?
X cubed.
4.
Or sorry, yeah, 4.
Okay, plus 10 times the derivative of x cubed.
3x to the 2nd, sorry.
Minus 6 times, what's the derivative of x? 1. Plus, what's the derivative of 5?
0.
0. So you say 8x to the 7th, plus 60x to the 4th, minus 16x cubed, plus 30x squared minus 6. The key to this, though, it does have to be written as powers of x before you can do your derivative. So if you have things being multiplied, you have to multiply them out first. If I asked you to find the derivative of x plus 4 to the 3rd, what would you have to do before you could do that derivative? Multiply it all out and then do the derivative term by term. If I asked you to do the derivative of like x to the 5th plus x cubed plus 4x over 3x, what would you have to do before you could do that derivative? Divide everything by 3x and have it as like 1/3 x to the 4th. 1/3 x squared. 4/3. So before you do your derivative, do any algebra so that everything is just x to a power. Then you can do your derivative term by term. I think I'm going to stop there for today. So I want you guys to try some. I'm remembering to simplify before you do any derivatives. So you are doing 3 through 17 odd, 23 and 29.